Okay, this is JV Stats section 1.5. This is an extremely long section, but I think it's the absolutely most critical section, probably of all statistics, is z-scores. I can't think of anything more basic in stats. This would be like the factoring of algebra or doing proofs in geometry. It's just so foundational that it's going to take a lot of time. The first thing I'm going to do is I'm going to go off the notes. So I'm going to slide down. Hopefully you have a blank piece of paper somewhere. I think I have one at the end. This is a 3-page deal here. So as always, I always tell kids on every video, stop the video as often as you need. That's the whole point of this. Is I'm taking very difficult concepts that take a long time to explain, putting them on a video so you can watch them anytime. So let's just talk about the normal curve qualities, which I didn't have in this section. Maybe I should have. Okay. So what you have in a normal curve is, first of all, not all data is normal. It's not all normal, but a lot of it is. Okay. And we'll talk about, what data comes in normal and what doesn't. But when data is normal, which is a phenomenon that happens quite often, the normal curve has certain qualities. Okay. And first of all, z-scores, the definition of a z-score is how many standard deviations you are above or below the mean. It is sort of it's a unit. And I equate it to, there's a lot of things in life that are units. For example, dollars as a unit. When you go to the grocery store and you look for the price of milk, they don't say, oh, the price of milk is 100 marbles or a big pile of dirt. They don't have things in funny values. When you go to buy a car, they don't say, oh, it's about 100 cows. Like, well, how much is that? We always convert everything to dollars because dollars is something that is universally understood really around the world. So there are things like that out there. The z-score is the conversion for how unusual is something. Well, if it has a certain z-score, you can consider it unusual. So a z-score is literally how many standard deviations you are above or below the mean. So if you are the mean right in the middle, your z-score is 0 because you don't deviate from the mean at all. So your z-score is 0, okay? If your z-score is 1, you're right around here on the curve. And if you're at -1, you're right around here at the curve. 68% of the data is actually located between 1 and -1 z-scores, which is about 2/3. Now, what follow this if you can, that makes the z-score of 1 the 84th percentile because it's 68 plus the 16% down here, since there's only 32% left in what they call the tails. This is, of course, the 16th percentile. Okay, so that's something to remember. All right, which is it's really handy if you know that. This is called the empirical rule. Empirical rule, and I'm going to be referring to that verbally as I go through this empirical rule. All right, I think this is important to know. Now, if you get the z-score of 2 and -2, okay, 95% of the data is within 2 standard deviations of the mean. It's almost the whole curve. Okay, it's really deep in the tails there. And then for percentile ranks, this is about the 97.5 percentile, and this is about the 2.5 percentile. Okay. And then when you get into the third standard deviation, that is way in the tail down here. 3. Remember, we also know that if you are outside of 3 or negative plus or minus 3 standard deviations from the mean, you're considered an outlier. You can see why in the tail here. Okay. And that area, I got to draw it up here, but that area covers 99.7% of the data. Okay. So the empirical rule is a really handy thing to understand. Okay. And then, like I said, the first z-score is the 84th percentile. The second is the 97th and a half. And the third is the, it's like it's almost 100%. It's 99.8 or something. There's a table that we're going to show you. Let me clear this real quick. You're going to be shown a table today as well. Okay, and on this table, the table pretty much, let me slide down a little bit. If you notice in the table, I'm going to show you how to look at this right now. The table is in hundredths. So we usually round z-scores to hundredths. Kids always ask about significant figures, but we have tradition, we go to hundredths, all right? So if you notice, we have negative 3.4 and it counts down here. This part right here is the hundredths. So this table stops at negative 3.49. And I'll mark it on here. Negative 3.9 is way down here. And there's only 0.02% or the proportion 0.002 below that point. So you're almost at the very end of the curve. Okay, so negative 3.4. Now on the other end, the table will go to, let me slide down here. The positive z-scores, the table is going to go to, whoops, lost you there. The table is going to go to 3.49, as you can see. Okay, and 3.49, of course, is 0.9998. And that, if I'll slide up here so you can see this, that is 3.49 is way down here and about right there. I mean, it's even further, and 0.9998 of the observations are behind it. It's almost the entire curve. So the z-score table basically goes from negative 3.49 to 3.49 standard deviations. If you get beyond that, you're getting into things that are either almost 0 or almost 100% in terms of percentile rank. In theory, it goes on forever. It does go on to infinity and negative infinity in theory, but it's such a small probability on there. But that's important to know because you can get z-scores of like negative 10, negative 11, negative 100. You can't. It just means they are so unusual, is what that means. Okay. So there's a couple of precursors here. Again, this is going to be a very, very long video, but it's going to be really, really helpful. It's very foundational. Okay. So let's go to the notes. Okay. And I have the answer keys, but I'll be trying to work it out as slow as possible. And again, stop the video anytime you need to. All right. So the first thing, parameter. A parameter is the actual value from a population, okay? And its notation is mu for means. That's not an M, that's not a U, it's mu. It's the Greek letter mu. Okay, and for proportions, they use capital P or pi. I like to use pi because I think it makes more sense to me because you're trying to stay with the Greek letters for everything. And then the statistic is from a sample. This class is AP statistics, not AP parameters. We study statistics or estimates or samples to try to estimate the truth. We see this all the time. What percentage of people will die from the coronavirus? Well, we're constantly trying during that time period, trying to get data to try to analyze that. Is it worse than the flu? We got to gather data on that to figure that out because life doesn't come with the answer, the parameter very often. Once in a while it does. You know that a dice is 1/6 sixes. You know that a coin is half heads. Once in a while, you know the parameters, but not too often. Okay. Now, a z-score, as I've talked about, it's also called a standard score, which makes sense because it's how many standard deviations you are above or below the mean. Okay. Now, this is one definition of it. Some books will have x minus mu over sigma, okay? if you have the actual standard deviation as opposed to S, which is an estimate. So it's the same idea. It's your number minus the mean of the middle divided by standard deviation. Okay, so go ahead and pause the video if you need to write that down. Great. So we're going step by step here. Step one in part two. I just want you to calculate the z-score on these. Just calculate it. No problem at all. Okay. So we have our score and the mean and the standard deviation. So I'm going to go 77 minus 71 divided by 3. No problem. And that's 2.0. Okay. B is going to be 18.3 minus 19.5 divided by 0.4. All right, no problem. That's -3. All right, this one will be 53.7 minus 51.2 divided by 5.2. Now here's the full answer, but we're going to round that to 0.48 because we're going to go to the 100th spot on standard scores because it's going to match the table. Okay. Now, sometimes in parts 2D, 2E, and 2F, sometimes the notation, this means normal curve. The first number is the mean, the second number is standard deviation. So normal curve, mean 12, standard deviation of 2. And X is our number. So we're going to go 9 minus 12 divided by 2, and we're going to get -1.5. Okay. The next one is going to be, the number is 87. We're going to subtract the number, the middle number, the mean, 91.4, and we're going to divide by the standard deviation of 5.7, and we're going to get that. We're going to round that to 0.77 negative, right? Because we're going to go hundredths on this. Okay. Now, here's the number that is the mean. Remember, if you are the mean, your z-score is 0 because you don't deviate from the mean if you are the mean. For example, if the average height of a male is 5'10", and I am 5'10", then my z-score is 0 because I am mean. I'm not deviating from it. I am the mean. Okay, so, but I'm going to go ahead and do the math. 49.3 to prove it to you. Minus 49.3 divided by 2.8, and that's the mean of 0. Okay. So what we have is we got 3 different levels of 3 different units in any problem. You have the raw score for the problem. Then you have that the standard unit of the standard score. Remember, like dollars is the standard and how we talk about money. Okay, pounds is the standard as we talk about weight. There are standards out there that we have, and the standard score for deviation is the z-score. Okay. All right. So you have raw score, you have a z-score, and then you can convert it to percentiles too. So there's 2 ways to do that. There's a calculator way and there's a table way. Now I have a table located on our Google Classroom, and you'll have tables in your book too. I'm going to be using the one I think from, I forget which book I got it from, but they're all pretty much the same. So here's, again, you're going to want to write this down, but there's basically 3 different scenarios. Okay. Scenario 1 would be you're going to shade to the left. Okay. So this question would ask, I want the area below a certain point, to the left of a certain point. Now, when you want to go to the left of a certain point, you're going to either use the z-table and just look right on that number. I'm going to be demonstrating that. Or you're going to get your calculator out, and I'll be showing you normal CDF, and you're going to put the lowest possible number on the left of a curve, which is actually -infinity. It actually is, but you can't type in infinity on your calculator because, here's my joke, you'll be there forever. Okay. So if you type in -100, -1,000, that's good enough. Comma, and then put your z-score number, put your number there, and that will also produce it, and I'll be showing you that. Okay. The second way you could be doing this is you could be shading to the right. You want to know the area above a certain number. So above a certain number, you're going to find that same z-score, and you're going to get a little number like for that spot that's not shaded, and you're going to go 1 minus that z-table, because we know the area under the entire curve is 1, okay, for 100%. Now to do this with the calculator, you want the area from the lower bound is your number, that's where my arrow is, and the upper bound is positive infinity. So this is actually infinity over here, but again, you can't type that in, so you'll just type in 100 or 1,000, okay? Then the next one could be between two numbers. So you want to know the area between x1 and x2. If that's the case, you're going to take the table number for x2 and subtract the table number for x1. You'll be left with that area. And then in the normal CDF, you're going to go the area between those two, left bound, right bound. Okay, this will all make sense to you soon. Okay, I'm going to be demonstrating that now. All right, what I'm doing next is we're going to walk you through some real simple problems here. Okay. Use a z-score table. So for the first through A through F here, we're going to use the table to find the area above and below these numbers. Okay, so this is going to be real simple. Okay, so we want we want the area below 0.8. No problem. Okay, so I'm going to go to my table, which is right here. Okay, and remember I'm going to look up 0.80. Okay, so going to look up 0.80, and as you can see, 0.80, 0.8, and then here's O, is 0.7881. Okay, and that makes sense. I'll draw a quick picture on the screen here. If you remember, I told you at the very beginning, a z-score of 1 is the 84th percentile. So 0.80 is just inside of that, so it will be a little bit less of an area than 84%. That makes sense. So that I'm talking about this area here. If you wanted to shade it, you could, but that's the area below 0.80. So if you are in the 80th percent, if you have a z-score of 0.80, excuse me, a z-score of 0.80, then you are in like the 79th percentile. Okay. All right. Fantastic. Okay, the next one, I got to go back and forth on this, will be a z-score that's greater than, so greater than negative 1.32. No problem. Greater than negative 1.32. So let me go to this, and I'm going to look up negative 1.32. Okay. All right. Negative 1.3, and then here's 2 right here. Negative 1.32 right there. Okay, now that's the area below below. Okay, remember negative 1 is the 16th percentile, right? 16th percentile, 0.16. So negative 1.32 will be a little bit less area, and it's this right here. But the problem says I want the area above that, not below that. So I'm just going to go 1 minus 0.0934. 1 minus 0.0934, no problem. So let's check and see how that looks. Okay. Yep, and 1 minus 0.0934. It's about there's about 90% of the data is within there of 0.09066. Okay. All right. And then part C is the area above 1.78. All right, 1.78 is pretty close to 2. Remember, 2 is pretty deep in the tail. Okay, so I'm going to look up 1.78. That's 1.7 here, and then where's 8? That's got to be 9, so it's got to be right. Right, I think that's right. 1.78. Yep. 0.9625, 1.78 there. I think I got that right. Let me slide this up a little to see. Yep, 1.78, I got it. There we go, 1.7. All right, and I want the area above that. So if I draw this out like I've been doing, just to give you a sense of it, remember here is 1.78 is right there. So the area below that is pretty massive, about 96%, but the area above that will be 1 minus that number. Okay, as you'll see in my answer. Okay. Yep, 0.0375. And by the way, although we round z-scores to 2 spots, we round percentiles to 4, just so you know how we do that. Okay, then 3D, the z-score below 2.06. Z-score below 2.06. Okay, z-score below 2.06. All right, so let's look up 2.06. 2.0 is right here, and then 2.0, 1, 2, 3, 4, 5, 6. 2.06 right there. And that is the area below, so that's the answer, 0.9803. Okay, that one's pretty easy because that's just the area below, which is directly off the table. Okay. All right, there it is, 0.9803. Clear that real quick. We had the answer right here. That's the one I just did. All right. This one, we have the area above negative 0.35. Okay, negative 0.35. And by the way, z-scores aren't percentages. They are the number of standard deviations you are above or below the mean. So, but people see a decimal like 0.35 and they think percent. It's not. It's a fractional z-score. So the area above negative 0.35. Okay. The above is a 1 minus. You can see my answer there. But let's go ahead and see how we got that. Okay, so let me get over to the table here. Negative 0.35. Okay, negative 0.3. Negative 0.3 is here, and then 5 is here. Negative 0.35 is, there we go, 0.3632, and I believe it was the area above, so we got to go 1 minus that. It's in the 60 percentiles, okay? All right, so let's make sure we got that correct. Yep, 0.6368. And the last one, the area below negative 1.4. That's not much of an area. That's very, it's under 10%, as you can see. Negative 1.4. All right. So negative 1.4. Okay. It's negative 1.40, and it's right there. 0.0808. Again, drawing the curve out real quick. Negative 1 standard deviation is the 16th percentile. So negative 1.4, you're even deeper in the tail. So the area below that's getting even smaller than 16%. It's about 8 or 9%. I guess 8 if you rounded that. 0.0808. Okay. Good. Okay. All right. And now let's use the calculator to do this, okay? Okay, using the calculator to find the area here. Every calculator is different. So, I have one that's, kind of the middle level. There's just so much variety out there. I'll try to point out the differences. You may have to get my help in class just one time and you'll get it. But okay, you're gonna find your calculator, find the area, this one below -2. Now, in this case, just so you know, below -2, we've kind of talked about this. You're around 2.5%. And that's the exact answer, 0.0228. Let's show you how to get that. What you're going to do is you got to label your left and right, your lower and upper bound. So the lower bound for less than 2 is all the way to infinity, right? So I want between negative infinity and -2. Now I'm not going to type in negative infinity. because that's ridiculous. That would take, negative 100 or 1,000 is fine. Okay, so I'm going to go lower bound, upper bound, negative 100, negative 2. Okay, so let me go to my calculator. Maybe I can leave that on there so you can see it. Okay, here's the calculator. Yeah, that'll work. So let me go back to second quit. I'm going to go stat, calc. Oops, I'm sorry. Second distribution. There we go. Second distribution, second bars. Normal CDF. Hit enter. Now, in some calculators, it's just going to have a parenthesis show up. I'm going to type in negative. By the way, that is basically negative infinity. I can put negative 100 in there. And when you go to the negative number, use the negative below the 3. For some reason, the negative over here doesn't always work, the minus. And the upper bound is negative 2. Okay, do you see that? Now, the reason this is 0 and 1 is that's the standard normal curve. The normal curve has a z-score of 0. The mean is 0, right? Mean is 0, and the standard deviation is 1. Just leave that. Some calculators you don't need to put that at all. I'll put paste. So for some calculators, you're going to do this, just so you know. It's going to be NCDF, and when it pops up, you'll just get a parentheses and you'll put in negative 100 comma negative 2, then you'll just close it and then you'll be done. It'll do the same thing. Okay, and I'm going to go ahead and hit get back to this. I'll hit enter. And you have to round to 4 spots because 4 spots is for a percentage while 2 spots is for a z-score. So 0.0228. You can see the answer there, 0.0228. All right, I'll write that out for you just so you have the rounded answer. Some people like the table better. Some people like the calculator better. I don't know. Just whatever you want. Okay. So there's that. All right. So the next one is the area above 0, a z-score of 0. I'm not even going to do this one. I should know this one off the top of my head. The area above 0, here's 0. The area above that is 50%, 0.5000. Okay. All right, let's go ahead and clear that. Okay. 3I, the z-score, the area below 1.3, below 1.3, no problem. Okay. So what I'm going to do real quick is I'm going to draw this, the area below 1. So I'm doing this over here. The area below 1.3. I know 1 is the 84th percentile. So 1.3, the area below that is gonna be greater than 84%. And you can see the answer is not, about 90%. Here's the answer. So I need to type in the lower bound, negative infinity, then the upper bound, 1.3. So negative infinity, which I'm going to use as negative 100, and then 1.3. Okay, so let's try that one. All right. So 0.3, memorize that there. So I'm going to go clear that. Second distribution in CDF. By the way, CDF stands for cumulative distribution function. Negative 100, comma, what was that? 1.3. I think that was what we were doing. All right. And it's 0.9032 because you're going to round to 4 spots. All right. If you remember that, you're going to round to 4 spots. Okay. Look at the 5th number. It's greater than 5 or greater. Okay. 0.9032. All right. Very cool. Okay. The next one, the area below 0.25. That's a fractional z-score, not a percentage. A fractional z-score. So I know the area below 0 is 0.5. That's the middle. So 0.25 is really pretty close to 0. There's 0.25 right there. So I need between negative infinity and 0.25. okay? Between negative infinity and 0.25, no problem at all, okay? Negative infinity and 0.25, okay. So I'm just going to go to my calculator and handle that. No problem at all. So clear that. Second, distribution. Normal CDF. Negative infinity is already there. And 0.25, I should get over 50%. And I do. 0.5987. Rounds pretty easily at 4 spots. 0.5987. Again, round to 4 spots. So I'm going to do those 4 right there. Okay. Sound good? Okay, so the next one, K, the area greater than negative 1.48. The area greater than negative 1.48. All right, that's going to be a pretty large area if you think about it. Let me draw that out. Okay, so the area above negative 1 is 84%, above it. So negative 1.48 down here, it's pretty deep in the tail. So the add area is, it's going to be 90%-ish, all right? So I need positive infinity now here, okay? So my lower bound is negative 1.48, and my upper bound is infinity, which I'm going to do positive 100, okay? So I'm getting the area above it, so the 100 is going to go into a different spot there. All right, here we go. So I'm going to go second distribution in CDF. Negative, and again, use the number below the 3, 1.48. And the area above is 100, because that's infinity, basically, is what I'm doing. 0.9306, because I'm going to round to 4 spots, 0.9306, okay? All right, so there's that one. Clear this real quick while I'm here. Okay, and the last one, the area above negative 3.14. That's going to be almost the whole curve, okay? The area above that, which is almost 100%, all right? So again, we draw it out. We draw this out. I think that's important to see, okay? Here's the drawing. Negative 3.14 is really deep in the tail, okay? Negative 3.14, and then the upper bound is infinity. Negative 3.14 infinity. Okay? All right, let's try this. Okay, so we got negative 3.14, and the upper bound is basically infinity. Here we go, 0.9992. So it's a lot of the curve. Okay, again, round of 4 spots. I keep saying that, but 4 spots for percentages or proportions, 2 spots for z-scores. Why? It's tradition, you match the table. All right. Okay, so let's go, oops. All right, so let's go to the next set of problems. All right, now we're going to start doing the next 2 pages. 1, 2. We got a lot of work to do. Okay, we're going to be converting raw scores and percentiles. Okay, so I've developed a system that I think is really helpful. This is not in any book I've ever seen. Okay, but it's awesome. What I did is you have 3 different units on any word problem. You have the raw score, the problem itself. You might be dealing with inches in height. You might be dealing with pounds. You might be dealing with, miles per hour. But that's going to get converted to a z-score, which is how many standard deviations you are away from the mean. And then that's going to get converted to a percentile. So there's 3 levels: the raw score of the problem, then the z-score of the problem is the middle level, and the percentile. And you can go forwards and backwards too. We're going to see all that. It's going to be really cool. Okay. So this is where the meat of the problems are going to come. Everything else has been kind of warm up. So whenever you do this, I always want you to sketch the drawing. Every single time, sketch this drawing, okay? And you can write all of this down. Pause the video, right? Get that all dialed in. But every time we're going to sketch this, and I often use R, Z, and percent. I didn't write that very good, but R, Z, and percent, because raw score, Z-score, percentile, okay? And this is going to be great. We've got many problems here. We're going to go forward and backwards. Most of mine are percentile rank, which is the area below. But just so you know, you could do the area above too, just so you know. But I do mostly percentile rank in this particular video. Okay. So once you get that written down, we're going to continue. Okay. All right. So again, most of these are percentile rank, which is the area below. So it'll mostly be pretty simple here. All right, the mean test score for the class was 81 with a standard deviation of 8. All right, pretty typical. You got a test, and I get all the scores out there, and the average was an 81. Okay, a B, a low B. Standard deviation of 8. Find the percentile rank of someone who scored a 92. All right. You can see the z-score. How I got the z-score is I went 92 minus 81 divided by 8. And that comes out 1.38. So I went from here down to this level. Now I'm going to look up 1.38 on the chart and see what percentile rank that is. You can see the answer already, of course, but let's go ahead and check it out. 1.38 on the chart. Mouse, there we go. 1.38, and it's the area below, so it'll be the exact number on here. Okay. Whoops. Go this way. Okay, 1.3 and all the way to 8, which is right here. 1.38. 0.9162. No problem. Okay, 0.9162. Write the answer down and you're done. The percentile rank is about the 92nd percentile if you wanted to do that. Okay, fine. Okay, 0.9162. Now you can do that on your calculator, of course, as well. And if you did it via the calculator, then you put in second distribution, and the area below 1.38 would be negative infinity, and then 1.38. All right. There you go, 0.9162. All right. I'm putting it all together now. Hopefully this makes total sense to you. Okay. Let's see here. Clear that real quick. Okay. B scored a 70. Okay, scored a 70. All right, on the same test there. So 70 would be, I got to get the z-score. So I know you can see the answer. It's negative 1.38, but I'm going to go ahead and do that. So 70 minus 81 divided by 8, and that's negative 1.38. And that's pretty deep in the tail there. Now, if you're smart and you realize, oh my gosh, these are opposites, 1.38 and negative 1.38. So they have to add to make 1. You could figure out the answer that way. So I'm looking for this little area right here, okay? And remember, the bottom is negative infinity. Oops, that's an 8. Negative infinity, okay? And the top is 1.38, okay? I'm going to go calculator on this first, okay? So I'm going to do, let's see here, second distribution and CDF. And I want the area below, so negative infinity is negative 100, and then this will be negative 1.38. Again, use the negative below the 3 for some reason on most calculators. Okay, there it is, 0.0838, 0.0838. Now on the chart, which you could do as well, I'm going to look up negative 1.38. That's up here. Negative 1.3, and then I'm going to go all the way over to the 8, which is right there. Okay, negative 1.3 and then 8 right there. Okay, and again, most of my examples that I have today on this particular worksheet or notes here is the area below. I didn't do the area above a whole lot. I probably should have a little bit more, but that's okay. All right. Next one. The mean height of an LQ girl is 64 inches. That's 5'4", okay, with a standard deviation of 2.5. That might be accurate, I don't know. Find their percentile rank of an LQ girl who measures 6 feet tall. Now, that's a pretty tall girl for our school, 6 feet tall, okay? Fairly tall. My daughter is 6 feet tall, and she's definitely in the 99th percentile. So let's check this out. So the first thing I'm doing is I'm going to get the z-score, which is going to be 72 minus 64 divided by 2.5. And that goes right there. So that's a z-score of 3.2. You say I drew it pretty accurately. And the percentile rank is the area below it. So all this shaded area below it. By the way, I forgot to fail to mention, you label the standard deviation up at the top on the drawing, and you label it to the first deviation, which is, remember, that 84th percentile. That's how you're supposed to customarily do it, okay? Now look at that z-score of 3.2. That's really far in the table. You know that's the 99th percentile because I've taught you that already. So z-score of 3.2, wow, that's very, very deep in the tail. Okay, so let's check it out. Let's do the calculator way first. Sound good? All right, so I'm going to go second distribution in CDF, negative infinity, comma, 3.2. Sound good? 0.9992 or 3, 0.9993, okay? Sound good? Awesome. The other way to do that, of course, is on the chart. So it's the z-score was 3.20. That's going to be down here. Okay. 3.20, and it's the very first entry right here, 0.9993. Okay. Sound good? Fantastic. All right. Let's get to the next one. Whoops, I lost everything. What did I do? There we go. Let's get to the next one here. Okay. All right. A La Quinta, the mean male weight of a La Quinta kid is 155 pounds. I have no idea if that's true. That's made up data, by the way. With a standard deviation of 14, I'm assuming it's all normal. Find the percentile rank of a La Quinta male who weighs 130 pounds. And again, I'm doing only the area below on this particular worksheet. It could have the area above. So 130 is area below, right? If you draw it accurately, you'll get the idea that's a pretty small percentage. Remember, put the standard deviation in the drawing to the first level there, to the first first z-score. Okay, first z-score, that's where you customarily put it. All right, so it's going to be a negative z-score because you're below the mean. 130 minus 155 divided by 14. Okay, and then there's your z-score is negative 1.79. Okay, and then we need the area below that. Okay, so let's just go ahead and go on the chart this time first. Okay, and then I'm going to go negative 1.79 up here somewhere. Okay, negative 1.7, you can see it. Change colors here for you. Negative 1.7 and go all the way to 9. And I believe there it is, 0.0367, the area below the mean, below that number, negative 1.79. All right, the other way to do that, of course, is on your calculator. I'm not doing this a lot. You probably got the hang of it already. So second distribution and CDF, it's the area below. So I negative 100 and what do we got? Negative 1.79. Okay. 0.0367. Sound good? Okay. All right, fantastic. All right, next one. 185-pound kid. That's a larger kid at our school, 185. So we're going to take 185 and we're going to subtract the mean. And we're going to divide it by the standard deviation. And you're going to get 2.14. Now, the area below that's pretty significant, okay? So here we go. 2.14. So I'm going to look that up on the calc and the sheet first. All right. So here's the formula sheet. 2.14 is down here. So let's see here. Perfect, right? Somewhere in there. 2.1. 2.10, 1, 2, 3, 4, 2.14. 0.9838, okay? On the calculator, that will come out, again, area below, second, distribution, NCDF. This will be 2.14, all right? 0.9838. Go to 4 spots on that. 4 spots right there. Okay. Okay. Next. Okay, so that's the first 6 problems there. Okay. Now the next one would be SAT verbal. Okay. The mean SAT. Did I forget one? I think I forgot one. Oh my goodness, I forgot to do 4D. Come on. Come on. Let's try that one. My bad. 4D. All right. So 62 minus 64 divided by 2.5 is 0.8. So it's almost -1. So it's probably right around there, a little off. Okay, so the z-score is -0.80. No problem. I'm going to look at -0.80 first of all on the chart. -0.80. Okay, -0.80. It's a pretty easy one to find. First column, -0.80, 0.2119. All right. Then on the calculator, I'm going to go, let's see here. Second distribution, NCDF, -infinity. What was that number again? It was 0.8. Jeez, a lot of numbers dancing in my head. -0.8. -0.8. All right. 0.2119. 4 spots. Okay. Again, I'll circle that for you. Go to 4 spots. So it's 0.2119. Okay. Let me clear that. Got a little bit going. Okay. Finally, now. So I went out of order. That was weird. Okay. The mean SAT verbal it was 496 in 2013. The standard deviation of 120. All right. Sounds good. Jake's score was at the 65th percentile. All right, we're going backwards now. Backwards is called the inverse, okay? So you're given this number, so you're going to write that out. You're not actually given this one initially, okay? You're not given the z-score. but you're given the mean, which you're putting in the middle, and you're given his, you're not given this initially. I'll show you that in a second there. So that's what you're given is the percentile. So you have to work back up. Okay, so that makes this a little bit different. So we've got to do the inverse. Instead of taking the z-score and finding the percentile, we're going to find the percentile, have the percentile and find the z-score. Okay, and that is a fairly different idea. Okay, but it's easy. Okay, so this is really a lot easier on the calculator, but I'm going to show you how you would do it on the chart in a second. What you would do is you would find the closest z-score to a percentile of 65%. And you see the answer is 0.39, but I'll show you what's going on. Okay, so I need to find 65%. I know 65% is in the positive z-scores. Okay, and so I'm looking for it in here. You can see where my cursor is. I'm looking for it, 65%. And it looks like 0.39 is the closest one. Okay, it's 0.6517. So I did the inverse. I went backwards. And now, okay, now I know that the z-score I want is 0.39. Now there's another way to do this on your calculator, of course. It's called the inverse. So you're going to go to your calculator and you're going to go second distribution and you're going to go inverse norm, which makes total sense, and type in the percentage you're talking about. And this was 0.65. Now, this calculator has, do you want it to the left of the number? I always leave it left. Just get the area below that because that's what the table does, is to the left. Every calculator is different. You might just end up typing in, inverse norm, come on, norm, and then 0.65, and then that's it. You might be done. And after that, depending on your calculator, you have to play with it a little bit, have the answer that we have, and then go down from there. Okay, I'm just going to paste this here. There it is, but you got to round to 2 spots because it's a z-score. The z-scores go to 2 spots, 0.39. There we go. Okay. So now that I have that, I'm going to go back to this right here, and I'm going to write that down. All right, so it's 0.39 goes right there. Okay, 0.39. Okay, so how did I get this answer? Well, I got the z-score of 0.39, and that's going to equal the number I'm looking for, x, minus the mean of 496 divided by the standard deviation of 120. Then I solve for x using algebra, okay? And that's going to give me this answer here, okay? So that's a cool problem. Now let's do 4H. Maybe you'll get the hang of this. What score must Jake get so that he's in the 75th percentile? All right, so in the 75th. So when you first get this, you don't have these, okay? You just have 496 and you have the 75th percentile, which it's a little bit off. It's more like in here, whatever. Okay, you get the idea. 75th percentile. All right, so I'm going to go backwards to get the z-score for the 75th percentile. Okay, so the easiest way is my calculator. So I'm going to just do that for right now. All right, so I'm going to go to my calculator and I'm going to go second distribution, inverse norm, 0.75. Whoops, something wrong again. Try it again. Second distribution, inverse norm, 0.75. Man, I messed it up again. So you don't go too fast, kids. This is what messes you all up. Second distribution, inverse norm, item 3. Man. Oh man, I'm a disaster right now. Second. Quit. Try this all over again. Second distribution, inverse norm. Oh my goodness. That's like a blooper. I'm going to leave that. I'm going to leave that on there because that's so entertaining how bad I was right there. Inverse norm. Enter. 0.75. Whew. Hit paste. Now, what's interesting is this is, I say this a lot, but it gets confusing for kids. This is 0.67. 0.75 was a percentage. 0.67 is a z-score. I know they're both decimals. Just be careful. People get those confused, okay? 0.67 is 2/3 of a full standard deviation. 0.75 is 75%. So it's a different unit, okay? Now, if you wanted to stick with the table idea to get that, what you got to do here is you got to go to, you got to look up 75%, the closest number to 75%, which is, let's see here, 0.7486 right here. Okay, it's this number. This is the closest you can get to 75%. Okay, so it's 0.6, and then this column is 7. 0.67 is the z-score. If you're going to do the inverse off the charts, which is fine too, 0.67. All right. That being said, here we go. So what I did is I went from here up one level, 0.67. Now to get this answer, I'm going to use my handy formula. The z-score, 0.67, equals the number x, which I don't know. It's going to come out this number that I'm circling, minus 496 over 120. And then I'm going to use algebra to do that. So basically I'm multiplying 0.67. I can do it real quick, which is, it's really easy. I probably should do it for you. So it's going to be, you can see it off the screen there. It's going to be 0.67 times 120. And I'm going to, and then add 496. Okay, there's your answer. All right. So I went backwards, which we're calling the inverse, but it's going backwards. All right. So the first page, the previous page went forward. This one's going backwards. All right. The next one, I got some stuff that's the middle 50% of test takers score between what two values? The middle 50% of test takers. The middle 50%. All right. The middle 50%, if you remember in a box plot, I'm going to draw a box plot here. The middle 50% is the 75th and the 25th. So I started with this right here, 75th and 25th. Okay. Now the z-scores, I didn't round them. I should have put 0.67 and negative 0.67. Okay. And that's something, it's kind of good to memorize that the 25th percentile is a z-score of negative 0.67. The 75th percentile is a z-score of 0.67. Okay. So let's give this a whirl here. Okay. Let's go to let's do inverse norm. Okay, I'm going to stick with that one. So I'm going to go second distribution, inverse norm, 0.75 because it's the 75th and 25th. Enter. Great. 0.67, second distribution, inverse norm, and I want the 25th percentile, which I know will be the opposite of the 75th because they are the same distance from 0, which is the middle z-score. And that's negative 0.67. Okay. So what I got to do is I got to do two separate problems here. Okay. So what I'm going to do is I'm going to go negative 0.67 equals x. This, I don't know this number here, Illinois. X minus 496 over 120. And then the second one, 0.67 equals x minus 496 over 120. Okay. All right. Sound good? So you end up with, you know, those two numbers, and then that's the answer between here and here. All right, fine. Now, J is the middle 80% of test takers. Well, the middle 80%, if you think about it, is between the 10th and the 90th percentile. If you think about it, 90 minus 10 is 80%, and that's the middle of the curve. So the middle 80%. So what I got to do is I got to go from here up a level. You see the answer is 1.28, negative 1.28. But how I get that is I'm going to do the inverse. Okay. So on the inverse, I'm going to go to my calculator. Okay. Maybe I'll show you the table too. So the calculator, we're going to go second distribution, inverse norm, 0.9. Okay. 1.28. I'll do the other one. You already know it's negative 1.28. Second distribution, inverse norm. It's going to be 0.1. Okay. That's going to be negative 1.28. All right. So those are my two scores. Okay. And you can see that already on the chart there. Clear that real quick. I'll put arrows to them. So I did the inverse to get those. Okay. So I did the inverse to get that there and there. Now, again, let me show you off the chart. Okay. How that would work. So let's go to 90%. Let's go to 0.9. Okay. We're going to look for the number that's closest to 90%. And I see one right here. This is, to me, this is harder, but right here, 0.8997 is 1.2 and then 8. Okay, 1.28. That sound good? That's about the 90th percentile. Then the opposite of that is negative 1.28. I'm sorry, is the 10th percentile. The 10th percentile, the closest number that I see is right here. And again, that's negative 1.28. So that's how you would do it off the chart to get that. Okay. Either way is fine. It doesn't make any difference. Okay. So once you get that, you're now going to set up your mini problems. So it's going to be negative 1.28 equals 8 equals x minus 496 over 120. And then I'm going to solve it. I'm going to get at approximately that number. Okay. And then I'm going to do 1.28 equals x minus 496 over 120. And I'm going to get approximately that number. Okay. Okay. All right. So the next one, the middle income of the U.S. was 72,000 with a standard deviation of 16 in 2014. The middle 60% of incomes are between what? The middle 60. Okay. So for me, oops, sliding down too much there. For me, the middle 60% is between the 20th and the 80th percentile. Okay. The 20th and 80th percentile. Now, so I need to get what the z-scores were. Okay. So I need to go, I'm going up, I'm going this direction, doing the inverse like I've been talking about. So I'm going to get the two z-scores, which you see there are 0.84 and negative 0.84. Well, let me just show you there. I'm going to get those off of the, I'm going to go calculator in this case. Okay. I will not do the table way this time. Well, maybe I should. Okay, let me clear the drawings there. So I'm going to go second distribution inverse norm, and they want the was it 20? So I want the 80th percentile. Okay, 0.84. Now I should already know if the 80th is 0.84, the 20th, which is the reflection, should be negative 0.84, but I'm just going to do it anyways. Second distribution, inverse norm, 0.2. There we go. Negative 0.84. All right, no problem. Now, I said I wasn't going to do up the chart, but I think I should, just in case. So let's go to the 80th percentile. Well, let's do the 20th first, since I'm running the space. The 20th percentile, the closest number is right here, 0.2005, and that's negative 0.84. Okay. Then the 80th percentile, which is going to be down the page here. The 80th percentile, the closest number will be 0.7995, and that's going to be negative 0.84. Okay. All right. Sound good? All right. Okay. The next one, the middle 90% of U.S. incomes range between what two amounts? Between what two amounts? Oh, I didn't finish this problem. Oh, come on. Long video. Didn't finish this problem. Okay, now, so I'm going to take my z-score, negative 0.84. I'm going to round to 2 spots. And I'm going to go x minus mu 72,600 divided by the standard deviation of 16,000. And that's going to come out this number, about 59,000 there. Then on the other side, I'm going to go 0.84 equals x minus 72,600 divided by 16,000. Okay, and that'll come out that number. And those are bolded for you for the answers. It's hard to see, but they're bolded. Okay. Now the middle 90%. To me, that's between the 5th percentile and the 95th percentile. So the two z-scores are 1.65 and negative 1.65. I know I didn't round them there, but I probably should have. Okay, 1.65 and negative 1.65. How did I get that? Again, you're not supplied with these answers at the beginning. You're going to have to work your way back up. So I'm working my way back up. Step 1, convert 5% into a z-score. Okay, 5% into a z-score. Let me use the table first. 5% into a z-score. Okay, so let me go up the page here. 5% into a z-score. So it's going to be negative. Where's 5%? Negative. There we go. So right about, I think this is the closest I can get. It's right in between here, 0.0495 in here. Okay. So I'm going to go negative 1.60, 1, 2, 3, 4, negative 1.65. Okay. Negative 1.65 right there. And then 95%, of course, will be positive 1.65, but let's try it. 95% will be positive 1.60, 1, 2, 3, 4, 5. Okay, so it'll be right about here. Okay. Be positive 1.65. Okay. Okay, perfect. So now to do that on the calculator would be pretty easy too. Okay. Second distribution in inverse norm. First thing I want is 5%. Negative 1.65, 64, You know, either one's fine. It's fine. It's 1.65, 1.64. And then 95% would be 0.95 there. 1.64. You know, I think I did 1.65, but either way, 0.64, 1.65. It's not going to make that much of a difference. Okay. So, all right. So let's go negative 1.65. I forget which one I did, equals x minus mu, and mu is 72,600 divided by the standard deviation of 16,000, which I put 16K there. That'll give you one answer. And then 1.65 equals x minus mu 72,600 divided by 16,000. Okay? Sound good? All right, so there is L. Okay, for K and L. All right, the next one there. The mean SAT verbal, this is the last two. These are actually hard problems. So this is going to be cool. So take a second to read this, and it's a tough problem. The mean SAT verbal score was 496 and 13, standard deviation 120. From her practice tests, Amber knows that she will score between 550 and 600 on that portion of the test. A tutoring company claims they can increase her SAT verbal by 100 points. If this is true, what would be her new percentile range? All right, no problem. Okay. It's not that bad. This is the forward way. This is the normal way to do things. All right, so basically I took 550 to 600 and added 100 points, which seems remarkable that some testing company would claim that, okay? And all I need to do, no, I don't have this information yet. I'm going to be producing that. So what I got to do is find the z-scores for that first, okay? So the first z-score will be 650 minus 496 over 120, okay? And then the other one will be 700 minus 496 over 120. And that's going to give me my two z-scores, which you'll see below there. Okay, the two z-scores of 1.28 and 1.7. Now I just got to get the percentile range in there, okay? It's between the 90th and like 95th, as you can see. But let's go ahead and get those numbers, okay? So I'm going to look up 1.28 on the chart here. 1.2, I'm going to go all the way over to 8, which is 1.28 right here. 0.8997. Okay, 1.28. All right. And then on the other one, 1.28. On the other one, I'm going to go to 1.70. Okay. So I'm going to go 1.70, and that's right here. And I think you know the calculator way by now, so I'm not going to do that, 1.70. All right. So there's your new percentile range on those. You can see those answers right here. And I went the normal progression, or the original, where I just went down and backwards, like, I mean, not backwards, I went straight down. I went from a raw score to a z-score to a percentile. That's pretty easy. Okay. All right. Okay, the next one says, a tutoring company claims it can increase her SAT verbal by 10%. So instead of saying in points, it says by percent. If this is true, what would be Amber's new scoring range? All right, so it's a little bit different, okay? So I'm going to do the original numbers first. So I'm going to take 550 and 600, okay? I'm sorry. Let's see here. Hold on one second. Okay, for this last one, I have a wrong answer. So I'm going to scratch all this out here. Oh, the horror of it. Okay, so let's look at this, okay? So it claims it can increase her score by 10%. So what we're going to do is we're going to get the percentile rank of 550 to 600. We're going to get 550 to 600. So let me just redo this whole drawing down below, okay? This will actually be good to do. I think it'll be better. Okay, so we got a situation where we got between, this is great, between 496 and 120, and we got between 550 and 600 as a practice test, somewhere in there. Okay, so what we're going to do is we're going to get the percentile rank for this and then just add 10% to it. That's all we're going to do. Pretty simple, okay? All right, so let's get the z-score for 550, okay, first of all right? So let's get the z-score for 550. So see if I can see this through here, all right? So 550, we're going to go 550 minus 496, enter, and divide by 120. Okay, so this has a z-score of 0.45. So let me draw that, 0.45. So we're actually a little further in here, 0.45. Okay, no problem. And then we're going to do the z-score for a 600, which I wrote as 60. 600. All right, z-score is 600. All right, so we're going to go 600 minus 496, and we're going to divide by something, 120. 0.87. All right, so 0.87. Okay, 0.87. All right, no problem. Now I'm going to get the percentile rank for both of these now too. We'll do that all at the same time. Okay, so let me get the percentile rank here. So we're going to go second distribution in CDF, and we're going to get the area below. I'll put negative 100 here. I'm going to get the area below 0.45 first, okay? And that is about the 67th percentile, okay, 0.6736, okay? I'm going to change colors on this. So we got, let's see here, 0.6736. This will come up better when we get back to the screen. And let me do the 87th percentile now too, the 87th percentile, okay? Second distribution, I'm sorry, a z-score of 0.87. In CDF, just change that to 0.87. And 0.8078, 0.8078, 0.8078. All right, sounds good. All right, so let me get rid of the this here. We'll go back to. All right, so what I did here is I converted her scores of 550 and 600 to percentiles, just the normal way. And that SAT company, so I'm going to round this to about 67%. Sound good? And this is 81%. The company says they can increase it by 10%. So that means they can get her to 77% all the way up to the 91st percentile, 91st percentile. Okay? So that's how you do that last problem. All right. That was a very long video. I know. Made some mistakes. Hopefully that makes you feel better about the whole thing. So, and if you need any additional help on that, obviously I'll do them in class, but that's a really good starting point. So stop the video whenever you need. Thanks a lot. We'll see you next time.